Let us now go over with the different sample problems for geometric progression. So number one, write the first four terms of geometric progression given a1 is equal to 3, or the first term is equal to 3 and the ratio is equal to 5. So what is the required? We are to identify the first four terms of a progression given the first term, which is 3, and the common ratio, which is 5. So for our solution, we have here our first term, which is 3. We are to identify the second, the third, and the fourth term. So since given ang ratio, which is 5, it would be easy for us to identify the successive terms. So sabi natin, for the successive term, this is simply the multiplication of the preceding term, which is 3 multiplied by the ratio. So for the second term, this is simply 3 times 5 is equal to 15. And for the third term, that is simply 15 times 5, which is 75. And for the fourth term, this is simply 75 times 5, which is 375. So we now have here the first four terms of geometric progression. This is now our answer. Next problem, find x of the numbers forming a geometric progression 9, x, and 81. So first, let us identify the given. First term is given to be 9. Second term is given to be 81. And we can say that n is equal to 3 since we only see 3 terms from this particular problem. And what is the required? We are required to find the value of x, which is actually our second term. So solution, if we know the ratio, or if we know the common ratio, we can just, it would be easier for us to get the value of ace of 2 since we will only multiply the first term multiplied by the ratio. But the problem is we do not know the ratio, so that's the first thing that we have to find, the value of r. So using this equation, ace of n is equal to a1 multiplied by r raised to n minus 1. So we know the value of the last term, which is 81. We also know the value of the first term. We know the value of n, and we do not know the value of r. So we have one unknown. Therefore, we can solve for the value of r. So substituting, that is 81 is equal to 9 multiplied by the ratio raised to, our n is 3 minus 1. So simplifying, ratio is equal to 3. So since we already know the value of our ratio, we can now get the value of the second term. So that simply is 9 times 3. So for us to be able to get this value, that is simply 9 times the ratio, which is 3. So 9 times 3. Second term is equal to the value of x, which is equal to 27, and this is now our answer. Next problem, number 3. Find the sixth term of the geometric progression 2, 6, and 18. Again, first things first, we have to identify the given. So the given is the first term is given to be 2. And we also know that n is equal to 6. So what are we required to solve? What is the value of the sixth term, or that is simply ace of 6? Alright, so for our solution, first we have to identify the common ratio. And the common ratio can be identified since we have the first 3 terms, and this is sufficient for us to be able to solve the value of r. So r is simply the ratio of the successive term divided by the preceding term. So that is simply a2 divided by a1, which is also equal to a3 divided by a2. So if we substitute this value, r is equal to, the second term is 6, the first term is 1, and 6 divided by 2 is 3. And if we are to consider also the third term and the second term, the third term is 18 divided by a2, and a2 is 6, so 18 divided by 6 is equal to 3. Thus, our value for the common ratio is 3. So from there, we can now solve the value of the sixth term using this equation. So a6 is equal to, we substitute, ace of 1 is given to be 2, and then r, the one that we were able to solve, that is 3 raised to n minus 1. Our n is 6. So ace of 6, or the sixth term, is equal to 486, and this is now our answer. And next problem, find the sum of the geometric progression for negative 12, 36 to 6 terms. So again, it would be easier to solve the problem if we list so that it would be easier to process. So identify the given. First term is given to be 4, and then n is equal to 6. And we are required to solve for the sum of the 6 terms. So to start, again, we can see that from the given first 3 terms of the geometric progression, we can solve for our ratio. So r is equal to a2 divided by a1, which is also equal to a3 divided by a2. So since a1, a2, and a3 are known, we can substitute. So r is equal to a2 is negative 12 divided by a1, which is 4. So negative 12 divided by 4 is negative 3. Likewise, a3 is 36. Third term is 36 divided by the second term, which is negative 12. 36 divided by negative 12 is negative 3. So this is now our ratio. So from here, we can directly use the equation for the sum of geometric progression. Since let us evaluate if we can directly substitute the values. So we know the value of a1 is given to be a4, and then r, we were able to solve it, and then we also know the value of n, and r, the same, we know this value, so we can directly substitute this equation. Therefore, the sum of the 6 terms is equal to a1 is 4 multiplied by the quantity 1 minus our ratio is negative 3, so that is negative 3 raised to n, 6, divided by 1 minus negative 3. So if we are to simplify this equation, we arrive at the final answer, which is negative 726. So the sixth term is negative 726, and this is now our answer. Next problem. The fourth term of a geometric progression is 189, and the sixth term is 1701. Find the eighth term. So again, we have to list the given. So the fourth term is given to be 189. The sixth term is given to be 1701. And n is equal to 8. So what are we required to solve? What is the eighth term? So solution. We have here our equation in solving the nth term of a geometric progression, but obviously we cannot directly substitute this equation. That is because we do not know the value of the first term. We do not know also the value of the ratio. So we have to think of other ways for us to be able to solve the ratio, so that once we know the ratio, we can solve the other unknown values. So since the value of first term is not available, we can use the available given, that is the a4 and the a6. So if we temporarily treat a4 as our ace of 1, and the the sixth term, we temporarily treat it as our third term, making it our n is equal to 3. And going back to our equation and analyzing it, since ace of n now will be our third term, which is known, a1 is also known, n is also known, then we can solve for the value of ratio. So substituting, our third term is 1,701. So our third term is 1,701. Our first term is 189, this one. And then the r, which is what we are trying to solve. And then n is 3 minus 1. So we only have one unknown. Therefore, we can solve for the value of r, and that is equal to 3. Alright? So the next is we have to solve for the value of the first term. So going back now to the original problem. So let me just erase. We now go back to our original problem. And to continue our solution, let us now solve for the value of the first term. Once we know the value of the first term, then we can substitute it again to this equation for us to be able to solve the value of our eighth term. So to solve for the value of first term, we now consider our a4 or the fourth term to be the last term. So if this is the last term, meaning to say our n is equal to 4. So using the same equation, that is ace of 4 is equal to a1 multiplied by the ratio raised to n minus 1. So a4, fourth term, is 189. First term is unknown. And then r, we were able to solve the value of r. And then n is, we will use n is equal to 4 instead of n is equal to 8. So substituting, a4 is 189, a1 unknown, the ratio is 3, the one we solved, raised to 4 minus 1. So our first term is equal to 7. We can also set, for the sake of comparison, we can also set ace of 6. We can also use this value to solve for the value of ace of 1. So if we make this as our last term, therefore our n is equal to 6. So using now the value of a6, so sixth term ace of 6 is equal to the first term multiplied by the ratio raised to n minus 1. So we know the value of the sixth term to be 1701, equal to the unknown first term multiplied by the ratio, which is 3, raised to our n is 6. So 6 minus 1. Therefore, a1 is, or the first term is 7. So both are, whichever value are you going to use, you should arrive at the same value of the first term because we have this ratio, common ratio. So since we already know the value of the first term, we can now solve for the value of eighth term. So that now becomes ace of 8 is equal to the first term multiplied by the ratio raised to n minus 1. So the eighth term, which is unknown, and then first term, we already solved it to be 7. R, we already solved it to be 3. And then n is 8. So substituting, that becomes 8th term is equal to 7 times 3 raised to 8 minus 1. And our 8th term is 15,309. This is now our answer.